Alright, hey guys, welcome to another episode of Bran Academy. As always, my name is Bran. I'm Mr. Wynn's twin brother. And today we'll be talking about chapter 13, which is on probability, okay? So this part of the notes, you don't have to write it. It is optional if you want to, but please follow along just to get the flow of how we're going to be doing these problems, okay? So, place your bets. You're going to throw a dart with your eyes closed, okay? And you're only assuming you're only allowed to hit somewhere in the circle. Okay, so let's assume you can't miss. Will you bet it hits the green or blue? Okay. Now, in regards to placing your bet, you probably want to see which one has a higher probability. Okay. So it is a circle. So what we're going to do here to find the probability of hitting the green, this might be pretty easy. Okay, probability of hitting the green. So the area, I think the first thing we always want to find, what is the total area of the whole thing, okay? The total area of the whole thing is a circle. Radius is 5. So what I want to do here, it's pi r squared. So it's 25 pi, total area. Awesome, easy. Okay, what about green here, green? Okay, what's the area of the green? Pretty easy. Area of the green would just be pi, in this case the radius is 3 squared, so 9 pi. Okay, pretty easy there. And let's say for the blue, same color, huh? Okay, what? I'm gonna change this. Oh shoot. Okay, I'm gonna change this to like, I don't know, let's go like magenta. Okay, for the total area. So now for the area of the blue, okay, this one is a bit tricky. Okay, this area right here, okay. This ring, by the way, it's called the annulus. Annulus. Yeah, that's what you call like a ring, okay, that surrounds a circle. So to find that ring, you would take the total area, so 25 pi total area minus 9 pi. When you do that, you should get 16 pi. Boom. Okay, so just looking at this, what has a bigger area ends up being the blue one. Okay, so you probably want to put money in the blue one, which is 16 pi. And just showing you in terms of probability now, in terms of probability, you probably want to take, not probability, you will take, right, the area of the green. So probability of the green, right, it would be 9 pi, right, divided by what? What's the total area? 25 pi. The pi's do cancel out, but we're going to scroll down later. I'm just going to scroll down. Okay, so it seems like in general you want to place the bet on the blue one because it's higher probability. That's the key. Okay, so the probability hits the blue. Boom. That's the probability. Blue area over total area. And we just did this math already, right? You're taking the total minus the green. Boom, 16 pi. And then you should get 64% to hit the blue. And obviously, if you can't hit anywhere else, the total percentage is 100%. Thus, probably hitting green, you would take 100% minus 64, okay, to get the green. Okay, so a little backstory, not backstory, but background on probability. Okay, now check this out. Okay, rank blue, green, and purple in order of likelihood. Okay, so find the probabilities. This is 1. Okay, this is 1. 1, 1. So in order to do this, I'm just gonna explain the work here. So take a look. Okay, focus on top here. Total area. Okay, what's the radius? This is 2 plus 1 plus 1. That's 4. Boom, radius is 4. So the total area of this whole thing, 16 pi. Boom. Okay. Purple. Look at the purple here. What's the radius? Just 2. Boom. 2 squared. 4 pi. Okay, the green. Oh, green here. Okay. So to take the green, okay, look at my highlighter. Look. Boom. This is the green. Okay. Well, I mean, that is not the green. That's the green and purple. Okay. So I'm gonna take this full circle. What is this full circle? The radius of this full circle here is 3. Okay, that 2 plus 1 is 3. So that's why I have here 3 squared. And now I want to subtract that purple. So subtracting that purple, radius is 2, right? And that will get me 5 pi. All right, we feel it? You see what I'm talking about there? Now to get the blue analyst, okay, this ring, to get this blue ring, obviously you want to take the whole thing, take this whole circle, which the whole circle is again 16 pi, okay? And then you subtract it by this right here, this is 9 pi. Okay, boom, subtract by 9 pi. And then that gets you 7 pi. In terms of changing into a probability, you just put it over the total, okay? Put the area over the total, and boom, you get the percentage. Bam. Place your bets. So technically, the blue right here, guys, blue is your money shot. Okay, 44%, right, if it's just random. Obviously, if you're aiming, chances are if you're a good aimer, you might as well just bet on purple. But in terms of like assuming no skill is involved and it's random, this is technically the bigger area, which will give you a better chance. In terms of Vegas betting, don't gamble. Actually, I don't know. Technically, when you play arcade games, it's kind of like gambling. You know, like you put a little coin in, try to get some tickets. Kind of like gambling. Just saying. So you take all these percentage and you basically put that percentage over 1. So 1 divided by 0.31 minus 1 will get you that. That's how Vegas comes up with their odds. Anyways, not important right now. That's just a fun fact. Onto the actual notes here, guys. So let's transition to the notes. This one. Okay, boom. Okay, let's go. Let's speed through these notes, okay? Chapter 13-3. Okay, we're doing this one first and then 13-1 and 13-2. There's a reason. This is just a better intro to probability. So the probability of an event is a number between 0 and 1, okay? 0 and 1. Why is 0 and 1, okay, for probability? Well, if you think about it, if you change them to a percentage, what would that be? To change a number to percentage, you move the decimal twice. So if you have 1 decimals here, move it twice, boom, boom. What percent do you get? 100%, okay? So that's where, when you're comparing 0 and 1, that's very similar to just saying 0% and 100%, okay? Fun fact. All right, the word P right here, P, the probability of something occurring, okay? So P represents probability. So an event that is certain to occur, like is 100% chance, you would say probability equals 1. So a pregnant woman will have a boy or girl. That is 100% likely to happen. I think last year someone made a joke. Someone said, "Oh, Mr. Wynn, it's 2019. You can't say boy or girl." And then so I came up with the word pain. Okay, so a pregnant woman will have pain. That is 100% to occur. Yeah, cool. An event that cannot occur, so cannot occur at all, the probability is 0. So a pregnant woman will have Thor being born. At least in terms of our world, I don't think someone can born the god of thunder. Is that him? The god of thunder? Yeah. Okay, an event equally likely to occur, probably 50% or 1/2. The probability a pregnant woman will have a boy or twins. That's excluding twins. There you go. Yeah, I don't know what bio teaches. I just remember XX chromosome, XY. So you guys and your jokes. Okay, we're just gonna move on here. Okay, what's important? There's a lot of words, man. I need to change these notes. When the same probability is assigned to each outcome of the same sample space, the experiment is said to have equally likely outcomes. Okay? Equally likely outcomes. If each outcome in a sample space has the same, it should be, if they have in a sample space has the same chance occurring. For example, if you roll a dice, right, 1 through 6, a regular dice, each outcome is the same, right? It's always 1 out of 6, okay, for a 6-sided dice, okay? That's what we call equally likely outcomes, okay? Kind of common sense. Okay, so in general, your quote-unquote formula, not really a formula. The probability, again, P is probability, okay? The probability of E, which is some event. The top here is the number of ways E occurs, okay, whatever you want to occur, over the total possible outcomes, okay? Okay, so now, just knowing that, let's switch over the gear to geometric probability. Okay, so we just basically add our geometry stuff here. We're going to talk about two-dimensional stuff first. So a segment. Okay, look at this segment here. So what? Just looking at the example, I'll be right here. The probability, okay, so P against probability. The probability of M is on KL. Okay, where's KL? Boom, this is KL, okay? So what are the chances of that? Well, right now, they don't give you values yet. So what they just want you to do here is you take what you want. So KL over, what's the total? What's the total segment here? The total segment is RS, okay? So that's how you write that probability. I'm going to do the example here, and you guys will do the exercises. So point X is chosen at random on AD. Here's AD. Find the probability that X is on AB. Where's AB? Okay, boom. So this is AB. So AB is what we want, okay? AB over the total. What's the total? AD. AB is 8. Total length is what? 16. 1/2, 0.5, or in terms of probability, I would prefer percentages here, okay? 50%. Boom, 50-50, not a bad bet. Okay, please do 1 and 2, and then we'll come back and check. Okay, so let's check your answers real quick. Shouldn't be too bad, right? M on QR, where's QR? Boom. The whole thing is ZP. Plug it in, 30%. And then QP, where's QP? Boom, that's 8. 8 over 10. Easy money, okay? All right. Just check part 2. I'll make another video. So check part 2 on the second link, please.